everyone, welcome to Study with Sanjay's classroom. Today we are going to study polyester. So we select the marker. Polyester. So what is polyester? Before going through the polyesters diagram, we have to know what is polyester. So let us know the definition for polyester. So what is polyester? If any dicarboxylic acid, for example, we can think about hexane dioic acid. So if any dicarboxylic acid reacts with any diol, we can take ethane 1,2 as diol. If these two thingy react, dicarboxylic acid and diol, then the product that is going to be formed is known as polyester. So definition for polyesters is, we can say, if any dicarboxylic acid reacts with diol, then the product that is formed is known as polyester. Okay, so let's see how polyesters is really formed. So for this we are going to take hexane as example. Okay, so let us take hexane 1,6-dioic acid. Hexane 1,6 dioic acid. And let us take ethane 1,2-diol. Ethane 1,2-diol. So we have our reactant, that is dicarboxylic acid. As dicarboxylic acid, we are taking hexane 1,6-dioic acid, and another reactant, that is any diol. So we are taking ethane 1,2 as diol. So let's see how the products are formed. Let us draw the structure diagram of hexane 1,6-dioic acid. Okay, so the diagram for hexane 1,6-dioic acid is, we have to, as it is hexane, so it's sure that there is going to be 6 carbons. So let us just make sure to draw the 6 carbon chain. 1, 2, 3, 4, 5, and 6. Okay, now we have to, in the last carbon chain, as it is carboxylic OH group, we have to make sure that there is C double OH bond. So it is its structural unit. Let us draw it down. COOH. And we have to all we have to do is we have to draw another OH attached with first carbon chain, and the rest of the thing that we have to draw is all the H. Okay, so we are done drawing hexane 1,6-dioic acid. As you can see, there is 6 carbon attached with 2 COOH functional unit. So we get hexane 1,6-dioic acid, and the name is 1,6 because the dioic acid functional group is attached with carbon 1 and carbon 6. That's why the name is hexane 1,6-dioic acid. Okay, so now let us draw the ethane 1,2-diol, another reactant, that is ethane 1,2-diol. So for ethane, we have to take 2C. So at first we are drawing 2C. 1 and 1, 2. Now see, Now we have to draw the functional unit of ethane, that is OH. Functional. Now we are going to draw the functional acid of diol, all group. So as alcohol, we have OH as functional unit. So we are drawing it down. OH, two functional unit, as it is di. So means there is two functional units. So we are taking two functional units. Okay, let us draw the H at first. So it's gonna be easy. Okay. So the rest of the things are only hydrogen bonds. That is H, 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 and one more H. Okay. So now we are done drawing the reactants, that is hexane 1,6 dioic acid, and another is ethane 1,2-diol. So now we have to focus over the products. So we must make sure that we have to follow a single trip. Now I'm going to show you that how we are going to make an polyester. Okay. So to make the polyester, we can follow a simple easy trick, that is we have to keep our focus over the OH and H. OH and the H groups, those highlighted ones. Okay, so what we are going to do is we are just going to remove the highlighted portions. That is, we are just going to remove OH, OH, H, and H and attach these two. That is all. So let's see how we are going to make. As I have mentioned earlier, that we are just going to remove them. So let's see. So if we remove OH from here, we are starting from first carbon atom of hexane dioic acid. So first carbon atom, you make sure to put a bond here. First carbon atom is attached with double O and move six carbons. 1, 2, 3, 4, 5, 6. All the H groups. Okay, so here we are, and we have the last carbon atom also contain a double O, okay, double bond containing oxygen, and now we are done removing the OH from hexane dioic acid. And remember, I said earlier that we are going to attach both of the reactants, so we have to remove the H from ethane 1,2-diol as well. So we are just going to attach the last product, that is ethane 1,2-diol, removing the H from both sides. So we are getting O, oxygen. With the going to be started from oxygen, as we remove the H, O, C, C, one more O, and all the H. I didn't even draw the hydrogen bonds of hexane 1,6 dioic acid. So let me draw them at first, so it's gonna be easier and clear. Okay, so that is all. We just remove the OH and H from hexane dioic acid and ethane 1,2-diol, and we are getting a polyester. So it is hexane 1,6 dioic acid. It is ethane 1,2-diol. So sorry for the spelling mistake. Ethane diol, and the remaining product is we have the product that we get, the only single product is the polyester, polyester. Okay, now we are going to So now we are going to know about biopolysters. Okay, so what is bio? As soon as we attach the term bio with anything like biodegradable, remember the definition for biodegradable, that was biodegradable is the biologically degradable things. So what is biopolysters? So now we are going to know what is biopolysters. Well, as the term bio is attached with the polyester, so we can easily say that polyester that is decomposed by microorganisms, that is decomposed biodegradably, is known as biopolyester. Okay, so let us write it down, so it's gonna be a better note for you. So we have the definition for biopolyester, that is polyester that is decomposed by microorganisms, is known as biopolyester. Well, so now a question may rotate in your or revolve in your head, that is what is how we are going to make, or from what we are going to make biodegradable or biopolysters. Well, we can skip this question. Let us not focus over how we are going to make biopolyester. Let us focus over the uses of biopolysters. So we are going to know how we are going to biopolysters in most probably further chemistry of advanced level. But so far for IGCSE, we can be just limited in this page, that is what is biopolyester, what is polyester, how we are going to make polyester, or they may ask for diagram of polyester and the uses of biopolyester. That is all for the polyester chapter. That now we are going to know the uses of biopolyester. One more thing is I must mention biodegradable polymers. So polyester is kind of a polymer. Yeah, we can say that. Yeah, can be made from lactic acid. That is not an important piece of information really, so we have to focus over the use of biopolyester. Well, the use number one is biopolyester can be used to make biodegradable plastic bag. Biopolyester is used to make biodegradable plastic bag. As you already know that a plastic is really acting as, what can I say, poison for our earth. So if we are going to start using plastic bag that is made of biopolyester, then it would be really great for earth. Biodegradable, biodegradable plastic bag. Plastic bag. Okay. One more thing is biopolyester is used in surgery for internal stitches. Okay. So imagine you are having a surgery, well, and your stitch that contain the plastic, what shall I say? Okay, plastic rope kind of thing. So can you imagine having a plastic a stitch, and that is not going to decompose or degrade, and it is going to stay as it is inside your body? How dangerous it's gonna be. So if in case of that dangerous thing we are using biopolyester, then it's gonna be more easier for medical science either, because that polyester, the thing that we are using for stitches, is not going to stay as it is. It is just going to degrade itself, degrade biologically after a few days, and the skin or stitches will be as it is, and it will be a wonderful result. So biopolyester is also used in surgery. Okay, surgery. Surgery for internal stitches. intermoist teachers. Well, that is all for the chapter polyester, and we are done with the chapter polyester of IGCSE. So see, it's so easier. It's really so simple chapter. The thing that we are scared of is of the diagrams. So now I hope the diagrams are even easier for you, because the thing that you are going to do is you are just going to join hexane 1,6 dioic acid and ethane 1,2 diol by just removing the OH from carboxylic 1 and H from diol 1, and just attach them. So you are going to get a polyester. So that is all for today, my dear students. And yes, stay happy, stay blessed, stay tuned with my channel Sanjida, Study with Sanjida. And one more thing is, I recently have started taking classes of international students from all around the world. So if anyone is interested, you may join online via Zoom. And if anyone is inside within Stilet, then they may join the live classes. For further information, anyone can email me. Thank you.